Okay, so in this video, we're going to talk about using trigonometry to solve for angles in right triangles. So in this case, it's going to be a lot of the same stuff as solving for sides, just going the other direction. And so we'll talk a little about that in just a second here. First thing we want to make sure to hit up is just the names of our sides. So this is all going to be based on which angle we're concerned about, which in this case, which angle we're finding. If I'm finding this angle, then straight across from it, that is the opposite leg. Right next to it, the leg right next to it is called the adjacent leg. And then the longest side is always the hypotenuse. If the angle's in a different spot, just be careful that it's always based on the angle. So this is the opposite leg. This one's the adjacent leg and the hypotenuse. Probably the biggest thing you could do wrong is switching up those adjacent and opposites, because you're going to not have a chance from the beginning. Then from there, once we've got our side names down, then we can start to talk about our three different trig ratios. So I'll go ahead and label our sides: opposite, adjacent, and hypotenuse. And then these things, remember, are just definitions. There's nothing deep to understand about these. It is literally just memorizing the word sine means opposite over hypotenuse. It is not an understanding thing. It is a know thing. So keep that in mind. It is just something you have to take the time to memorize. Cosine is going to be adjacent over hypotenuse. And then tangent is opposite over adjacent. Adjacent's in blue. So you just got to know those three ratios and what they mean. From there, I just want to remind you of kind of like what your trig equations have always looked like when we're solving for sides. They've always started off with one of the three trig ratios, sine, cosine, or tangent. That is essentially just telling your calculator which trig ratio you're talking about. Then we've always got the angle that's next. So this is your ratio you're using. Angle, that tells you, which reference angle you're using. So this side on the left is just telling your calculator, hey, I want you to look up the ratio of the opposite to the adjacent for a 35-degree angle. That is what this side is doing. It's telling your calculator what to look up. And then on this side of the proportion, these things here are your actual ratio in the triangle. So it really is just a proportion. We're looking up the ratio of a 35-degree angle for a reference triangle. We're comparing it to the ratio of our sides in the actual triangle we have. Now, when we do inverses, what we're going to be using to solve for that angle, instead of having an x here, we're going to have, if I can get this to go down, we're going to not know the angle. So we're going to see equations that look more like this. Tangent of theta. Theta is just a variable we use for angles quite a bit. You've seen that one before. Equals 5 over 12. Something like that. So in this case, we will know two of the sides, but we won't know the angle. And we can't type this into our calculator like this because we don't know what theta is. And so normal tangent, if you look up here, normal tangent, we put the angle in and it's going to tell us the ratio. We can't do that. So what we need instead is to use the inverse tangent. And so when we use the inverse, I could probably use the right, spell it right. When we use the inverse tangent, it's denoted with this little inverse symbol. So this is read as inverse tangent. All an inverse is it just switches around what you put in and what you get out. So normal tangent, we put in an angle and get out a ratio. With an inverse tangent, we put in the ratio. In this case, it'd be 5 over 12. And we will get out the angle. All right, so normal tangent is input the angle, output the ratio, and inverse tangent, you input the ratio, and you output, or you get out, the angle. They're just opposites of each other. That is all this is. So let's go ahead and take a look at like doing one of these. You're going to see this is probably the easiest part of this whole deal once you understand that inverse idea. So we're going to start by looking at labeling our sides just like we always do. So I'm going to go straight across the triangle. That's the opposite. Right next to it, that's the adjacent. The longest side is the hypotenuse, but we don't care about that one right now, so we'll just kind of leave it there. So if I'm seeing opposite and adjacent, I know I'm going to be using tangent. Now the big difference here is I don't know the angle, so I can put a theta in there because it's just an angle I don't know. But I do know what the tangent of theta equals. It is equal to 4/12 because I know the opposite is 4 and I know the adjacent is 12. Now, I would encourage you to write this out at least until you're comfortable with these. But the big thing that you have to have written down is the inverse. And so the inverse tangent, I'm just, again, exchanging my inputs and outputs. So I'm inputting the ratio, and I get out my theta. And now I've got my equation solved for theta. I just have to type this into the calculator. So I'll show you how to do that on Desmos here. So if I look, my inverses are not on this main screen. I have to go to the function tab, and you can see there's all my inverses. So I want inverse tangent, and I just type in my ratio, 4/12. And you can see right there, it tells me my angle, 18.43, whatever. Now we're going to just go probably to the nearest whole degree, so we'll just say 18 degrees. So if we go ahead and kind of talk through those steps that we just did. Step 1, we identified our sides. Step 2, we wrote our trig equation. Then we rewrote it as an inverse. It's spelled poorly. And so that means we switched input and output. And then we just typed it in our calculator. The nice thing about these is you're really never going to have to actually do any algebra. Once you can write down the ratio, write down the trig equation, turn it into its inverse by switching the inputs and the outputs, then you just type that into your calculator to get the angle. That's all there is to this. So let's go ahead and do this next one here. I'll leave those steps over on the side. So step 1, identifying our sides. Well, there's my angle. So straight across, that's the opposite. This longest side is the hypotenuse. And then this is the adjacent. I don't need that, so I'll just cross it out. Then to write our trig equation, I'm going to decide sine, cosine, or tangent. Well, I have opposite and hypotenuse, so that means sine. I don't know the angle, but I do know that the opposite is 8 and the hypotenuse is 22. Step 3 is rewrite as the inverse. So I'm going to use inverse sine. But that means I'm switching the inputs and the outputs. So this 8/22 is my output. That has now become my input. And I want to get theta as my output. So inverse sine, I type in the ratio. It tells me the angle. Then I just have to go straight to a calculator. I don't even need to do anything else. No algebra to do. Just typing in inverse sine of 8/22. So under my function, inverse sine, 8/22. And you can see there's my answer, 21 degrees. We will probably just go nearest whole number degree on all of these. Okay, last one here. I'm going to go ahead and let you pause the video, try this one out, and then come back to see the answer. Okay, so going through this one, I've got theta here. The side right next to it is my adjacent, and this is the hypotenuse. So I know adjacent and hypotenuse means I'm using cosine. I don't know my angle, but I do know that the adjacent is 7 and the hypotenuse is 15. Then I will rewrite this as an inverse. Inverses just mean that I've switched the inputs and the outputs. So I'm putting the ratio into the inverse cosine, and I'm going to get out my theta. Then I will just type that straight into my calculator. Inverse cosine of 7 over 15. And that says it is 62.1, so 62 degrees. That is all there is to solving for angles.